So, hello everyone, and welcome to this online platform, Ask AuxEn Anything. And as you all know, this is a weekend session that we conduct where and structural engineers can interact with us and ask their queries or doubts related to uh, any project that they are doing or any RCC steel design concept or construction site issues. So this is the 34th such session that we are conducting, and let's start with today's session. What we will do is, as we do always, let me just take up the queries on the Google form first, and then we will take up the queries from live chat. So the first query asked is the first query is from engineer Dinesh. He is joining us from Tamil Nadu, and he is asking. I'll just paste his query over here. He is asking how to model, analyze, and design three basement floor building when retaining wall and column are in same line. I think he had asked this question in the last session also. Is it? But we could not discuss it, I guess, because the query was not clear. Is it sufficient in ETABS to model column as line element and retaining wall as shell elements and apply soil pressure on shell elements? Any special check to perform manually for combined action in RC columns and retaining wall junctions? How to design a detailed junction of RCC retaining wall and RCC column? So what he's saying is in plan view, if I show you, what he's asking that let's say in plan, this is his retaining wall. Let's call it as the basement wall. And then there are columns over here. This is the plan view. And these columns are the building columns. And there is a soil fill outside. Okay. And building is inside. And in the sectional view, how it will look like. So in the sectional view, this will look like something. This will look something like this. That this will be my retaining wall. Let's assume that it is connected to raft. There's a raft that you have provided, so it's connected to raft, and then there is an RCC column over here. This is also connected to raft, and then at multiple levels you have your slabs. So let's say this is basement 1, basement 2, basement 3, and then this is ground slab. Okay, so this is ground slab, this is basement 3, this is basement 2, this is basement 1, this is, oh, I think I marked one level extra. Anyway, it's okay. You take it as lower ground, upper ground, suppose. So, and the soil fill is from outside. So there is soil fill over here. So his question is that do we need to consider anything extra? No, so see, now you need to first apply the soil pressures. So you apply the soil pressures as per the level. Level means, let's say the soil level is still here. So you apply your soil pressure. Also consider the water table. So as per the water table, you apply that. Now you first observe the wall behavior. That means you see And of course, column you have modeled as line elements, wall you have modeled as shell elements. That's fine. You can apply the lateral loads as non-uniform pressures on the shell. So whichever software you are using, they have this option of allowing you to apply shell pressures, non-uniform shell pressures. Instead, you have that hydrostatic pressure option. In ETABS, you can use the uh, joint. What do they call this? That ax plus by plus cz plus d equation. Joint. You can assign those values to joints. Finally, of course, they get assigned to shells. So whichever software you're using, accordingly, you can apply these soil pressures and then observe the wall behavior. Sometimes what may happen if your column is not, if the column is not stiff enough, then wall will the wall will show mainly vertical behavior. Okay, something like this. So you will get hogging movement or tension phase on the outside at the slab junctions and tension phase on the inside at the mid heights. So if column is not stiff enough, you will get this kind of a behavior. If your columns are stiff, if the building columns are stiff, then you will see some bending, vertical bending getting reduced, and you will see bending in the horizontal direction. That means in the wall movements, you will see this direction movements also, significant movements, that is. So first of all, as per the column stiffness, you may see different behaviors in the wall. That is the first thing. Any special check to be performed manually for combined action? So in these columns, as I told you, upon seeing the behavior, you first check what is happening, and then special checks means you may have to provide some additional. You may have to do some additional shear checks over here at this junction between the wall, basement wall, and the column. So here you may have to do some additional shear checks. Of course, again, that will depend on the column stiffness. So you do that additional shear check. You investigate how much moment is getting transferred to the column. Again, it will depend on the column stiffness. So if significant moment is getting transferred to the column from this from the soil fill on the retaining wall or basement wall, then you may have to consider the moment also in your column design. And design and detailing of junctions between RCC column and wall, as I just told you. Check for shears over here. If shear is not sufficient, you may have to provide shear reinforcements. In plan view, they will look like this, links in plan view. Sometimes we also provide bent up bars to add to the shear strength. So you may have to provide, sorry, like this, bent up bars like this, assuming that the pressure is from outside. So such checks you may have to do for your case. All right. Okay. So this was his question. Then we have got question from Mr. Ketan Mahajan. He is joining us from Jalgaon and he is a working professional. So let's see what he is asking. Can you please explain the concept of releases in steel truss? I have seen many consultants, they release the MZ MY for vertical and inclined members of truss. Also, some of them specify them as truss in specification. So this is the first part of his question. So releases, see, this is an actual truss. If you read the definition of truss, they are supposed to be pin jointed members. Okay, that is the definition that we study, and that is how we uh, analyze also our trusses. If you have done manual analysis for trusses, you will observe, or you might have seen, that we consider them to be pin jointed elements, and that's how we analyze them and find their internal forces, moments, etc. But in actual practice, when we connect the truss members, it's very rare to see the trusses getting joined, the truss members getting joined together with actual pin-like connections. We don't have actual pin-like connections. Okay, very very rare. There are some bridges in Punjab, old railway bridges, British time railway bridges, where truss bridges, where footover truss bridges at railway stations at a few locations in Punjab where they have gone for actual pin jointed trusses. So in our case, we don't have pin jointed trusses. Our general trusses that we fabricate are not pin jointed. So specifying truss as specification is not very appropriate. Okay, not appropriate because you are not able to connect these members through actual pins or pin-like assemblies. So it's not appropriate to apply or to assign trust specification to your members in stat. Then why do people do it? Because otherwise what happens that in trusses, see anyway because of the geometry when you will analyze the truss, the moments will be pretty low, isn't it? Because of the geometry, the moments are pretty low. But even for low moments, sometimes what happens, and because we use very light members, single angles or double angles, so even for very small movement, you may see utilization ratio in truss members going beyond 1, isn't it? So to ignore the moment completely, they assign this truss specification, and that's how they try to reduce the utilization ratio. Now, in doing that, what happens? If Why do these warnings arise? Because then there are no rotational restraints that these trust members provide. If you apply trust specification, then there are no rotational restraints that these trust members provide, and therefore you see this instability warning. Okay. At the connection level, for the release in MZMY, again it depends on what kind of support, actual support with column you are able to create. Generally, you may create a pin-like assembly. I'm not saying pin, but pin-like. So generally, we have slotted holes, and on one side we may have uh, yes, slotted holes will give you a roller-like assembly, and on one side you do the welding in such a way that movement restraints are not uh, provided by this truss to column joint, and it behaves more or less pin like. Okay, so therefore some people or even we also do it that we may provide releases at the truss ends, but this is more of a approximation because we are not creating actual pin like connections even at truss ends. Okay. Also, I want to know about the releases if first truss member rests on the bottom chord of another truss member. Does STAT consider the secondary member as truss, or the whole load of first truss is transferred to the bottom chord of second member only? This question is not clear. Perhaps you could uh, provide some pictures or sketch. This second part of the question is not clear. Okay. Then next query is from again from engineer Ketan Mahajan, and he's saying uh, what he is asking. Is there any criteria for expansion joint in a building? Criteria, I think in IS 456, sorry, in IS 800, it tells you about the expansion joint in steel structures. I mean, I don't remember it, but I think there is some criteria. But he is asking about a RCC building. Is there any specification in IS code whether we have to consider the expansion joint for this much large slab? I'm not sure. I don't know. I don't know. I don't know. Generally around 30 to 40 meters. If you are providing expansion joint in the building also, you may provide the expansion joint in slab. Otherwise, there are different strategies like pore strips. If you are not, let's say, if you're not able to provide expansion joints, you may provide pore strips. That means that you will leave. So in plan view of slab, suppose you have a large slab, you will deliberately leave this portion of the slab not cast. So you will cast this, then you will cast this, and let the temperature related expansion contraction happen, and then you will do this casting later. So this is called as a pore strip. So there is this strategy that you can provide. Otherwise, IS specification, I don't know. I will have to read. But generally, where if you are locating expansion joint in a building, if your building is pretty large, generally around 45 to 60 meters, we try and provide expansion joint. Okay. I have seen consultants keeping some gap between whole building. Is this correct practice? Yeah, as long as it is pure expansion joint, keeping some gap is okay. Of course, it has to be temperature calculated. Temperature related calculations you may have to do, that how much your slab or how much your element is expected to expand or contract. Accordingly, you should provide this gap. Sometimes this gap should also be checked for seismic effects. So whether or not it is satisfying the seismic gap requirement, that also you may have to check. Okay. So many a times what happens that instead of expansion joint, the critical action becomes your temperature, sorry, seismic related gap. Then a related question is from engineer Tamila Rasan. For pore strips, shrinkage strips, consultant bend and curtail slab and beam reinforcement. How to detail that one? No, so you see the basic principle will be that you want differential, you want to allow the differential shrinkages. So do not try to continue the reinforcement over here, and they will curtail their reinforcement at this junction. They will not continue the reinforcement in this pore strip. So try to keep this pore strip independent, and the reinforcements also, you will see that reinforcements are also not getting continued through the pore strip. Okay, wait. Let me just answer your other queries first. Then he is asking Mr. Ketan also, when I design purlins in STAT, they never match with SP38. Why is this so? I don't know. There you might what you are doing in STAT, and you check what has been done in SP38. See if you have applied the proper parameters in STAT. Okay. Generally, SP38 values will be more conservative. That means, let's say for 6 meters span, for let's say 1.25 meters entry to center spacing, or 1.4 meters entry to center spacing, 6 meter span. If in STAD, let's say ISMC 125 is passing, SP38 gives you ISMC 150. Okay. So generally it will give you more conservative sizes. So keep that thing in mind as well. Okay. Mr. Ketan is saying he has shared image on WhatsApp for the first doubt. Let me check. Okay, so he's saying his doubt was this. Uh, First truss member rests on the bottom chord of another truss member. So he has this type of situation where his one truss member, let's say this is his truss, and it is resting on this second truss, and then this second truss is resting on some columns. So generally what we do in such cases, this becomes slightly complicated, and it will depend on your situation also. First of all, try to have some vertical member of second truss over here. Okay, so try to re try to what should I say, try to modify the geometry in such a way that there is a vertical member of this second truss at this junction. So there must be a vertical member that you have over here. Then from this vertical member, now there can be different options. One of the options can be that you can have a bracket taken out from this member, from this vertical member of the second truss, and on that you can create a connection for this first truss member. So generally on the top of column, your first truss would have rested, let's say, under normal situation. Now here what we are doing, we have this second truss, we have a vertical member, and from this vertical member we may have to create some this is one of the options, stiffener arrangement. And then on this, your first truss assembly will rest. Okay, another option can be that you directly connect one member to this vertical member, again through some gusset arrangement, and the bottom cord also gets connected to uh, the vertical member of second truss, again through some gusset arrangement. So that would look something like this, that this green is, let's say, my vertical member of the second truss, and you create some gusset assembly over here, and your truss, this is now first truss, and this is the top chord of first truss, this is the bottom chord of first truss. So it gets connected something like this. So that is also another option. Will STAT do it automatically? No, you will have to tell STAT what's happening, how you intend to connect it. Load it will transfer. Load transfer it will do as per your uh, modeling, but specific connections you will have to tell the software. Any release to second truss? No, so it will all depend where your second truss is resting finally. It will be a case to case specific situation. Okay, where the second truss is connected, it will depend on that. Okay. Okay, so these were the queries asked on the Google form. Now what we will do is we will take the queries from the live chat. Let me just take queries from live chat. Mr. Magaj is asking, my floor to floor height is 3 meters along major axis. Along major axis beam is there, but on the minor axis beam is not there. So my height, okay, so he is saying, I think that his column is placed like this, let's say, and this is his beam. So this is the situation at, let's say, at 0, then at 3 meters again he has a beam. So at 3 meters there is a beam. Okay, yeah, at 0 meter he had a beam about minor axis also. At 3 meters this is the situation, and at 6 meters, at 6 meters again he has a beam about the minor axis. So this is at 0, this is at 3, this is at 6 meter level. So now what is this query? My floor to floor height is 3 meters. Uh, so my height, okay. How to take care of this double height? What are the parameters we need to input in STAT? See, if you are doing it in STAT, sorry, ETABS. If you are doing it in ETABS, don't do anything. ETABS is able to consider these things on its own. So you can check yourself let's say you are doing the, first of all, do the effective length method. So if you are doing the effective length method, you can go to the etabs output and you can check for the effective lengths that the software is considering. So automatically you will see that about the major axis, let's say about ZZ, it is considering the effective length as 3 meters. Okay. Of course, it will multiply it by the sway factors and all that, but the length it is considering is 3 meters. About the minor axis, you will see it is considering 6 meters. So this ETABS is able to do on its own. If you are using StatPro, then you will have to give the effective length definitions in StatPro. But ETABS is able to do on its own. You can just right click on the column design and see what are the lengths being taken by ETABS. All right. Okay. Then the next question is from Nihal Pradhan. Can we model shear wall in STAD? Yes, you can. You can model shear walls in STAD. There is option to model shear walls in STAD. There is this very good video by Mr. Sandeep from Illustrasa. So you can watch that video on YouTube. I'm sure you all of you know about him. So he has a very good video on shear wall modeling in STAD. Okay. So you can watch that and you will understand the process that needs to be followed. He has very well explained it. All right. Then Mr. Nihal Pradhan is asking, when we transfer file to Stat Foundation, it takes factored load for foundation. How can we design? I've never used Stat Foundation, so I am not sure what Stat Foundation does. But of course, the basic concept is that bearing pressure will be checked for service loads without combination, that is. So for service loads, and once you so this you will use to finalize the plan size of your footing. Once you finalize the plan size, then to find out the thickness, second step will be to find out the thickness of the footing. So to find the thickness, we will check it for the ultimate combinations. Either you can check it for ultimate combination, or the bearing pressure you can multiply it by 1.5, multiply and check and do the calculations for footing thickness. Multiply the bearing pressure by 1.5. So this is the basic principle, and I'm sure Stat Foundation also follows the same. Okay. Mr. Hiren Desai is asking, after how much time the pour strip needs to be cast? Construction time, I am not sure at this moment that what is the good time after which the pour strip needs to be cast. Anyone in the live audience, if they can give some comments on this, after how much time pour strip needs to be cast? Okay. Online Guru is asking, in case of CSH member. What is CSH member? Hollow section, I think. I'm assuming it's a hollow section. So in case of a hollow section member as a purlin, and the connection between rafter and purlin is welded, so do we have to release the purlin? It depends what type of welding and how the welding has been done between the rafter and purlin. Generally, if purlin is on the top of rafter, even welded connections will not give you rigidity. So in such a case, you may not assume complete movement transfer between the rafter and purlin. Okay, so it depends on how the connection is happening between the, okay, circular hollow section. So it should be CHS, not not CSH. But why are you using circular hollow as purlins? Generally, we don't use circular sections as purlins because the sheeting connection and the connection between sheeting and purlin then becomes slightly complicated. Then you will have to go for J bolts. If you are using circular hollow section as purlins, then try to go for J bolts in the sheeting to purlin connection. So my answer is that it will depend on how you are welding it, but it will be very difficult for you to get a proper moment connection and rigid moment connection between rafter and purlin in such situations. It is better to assume it as uh, pin supported or released at purlin to rafter ends. Generally, these PEB people, they assume certain level of continuity in the purlin because they are keeping the purlin on the top of rafter, so they assume certain continuity in the purlin to rafter. That means if this is my rafter in section and my purlin is going like this, so they assume continuity effect. Okay, and then they will have their connections or overlaps made somewhere over here so that it is near the point of, let's say, contraflexure. And that's how these most of the PEB suppliers do it this way. Okay, so you can also think of this that you can take the purlin continuous over the rafter, and then you can have your joint in the purlin at a certain location near the contraflexure point. That way you can take help of continuity effect in the purlin design. Okay, so three times he has pasted the same question. All right. Mr. Akash Babar is saying, please explain reinforcement detailing for a floating column from free end of cantilever beam. Should the reinforcement of floating column be embedded in the column below? No, but if it's a floating column from free end of cantilever beam, how will you take that reinforcement to the bottom column? That will not be possible for you. So he's saying he has a column below is, let's say, something like this, and there is this cantilever slab. Sorry, cantilever beam, and this is the beam. This beam is continuing here. Then you have a column. So if your column is at the free end, how will you take this reinforcement till the column below? So that will not be possible. This is my column above, and this is the beam. So here the reinforcement, whether to embed it or not, will yeah, you should embed it, and the values will depend on reinforcement in this will depend on the moment at the base that you're getting. But then yes, you should develop it inside the beam. I don't think it will be possible for you to take this reinforcement to the column below. That won't be possible. So development length, uh, number one, you provide this LDC also over here. Compression length, development length in compression, that is to transfer the compression loads in this column. And then while calculating the development length in tension, you can take it from the complete bent also. So you give the appropriate compression development length and tension development length. Okay. Mr. Sunil Kumar is asking, please address some knowledge on shuttering design of piers of bridges in software. Okay, Mr. Akash is adding to this query. He has asked, cantilever span is less. See, if it is less, then you may have to check that generally the reinforcement, you cannot take a reinforcement slope steeper than 1 is to 6. So if your cantilever span is less and you have a column over here, this reinforcement you cannot have steeper than 1 is to 6. So if it is within that 1 is to 6 criteria, then you can take this reinforcement over here, not otherwise. Okay. So you will have to check your actual situation and try and see this. Mr. Sunil Kumar is asking, please address some knowledge on shuttering design of piers or bridges in software. So I have never done bridge piers shuttering, but generally not for piers. So for piers, I don't know. Uh, I mean, see, you need to check the concrete thrust, the horizontal thrust that concrete will apply when you are pouring the concrete, and uh, so as per that thrust, you may have to calculate the shuttering, but I have never done. So, I mean, I may not be able to answer this. Please address some knowledge on shuttering design of piers or bridges. So I've never done it myself, but then you need to know the thrust that your concrete in the pier is exerting, and then for that thrust or pressure, you need to check your shuttering. But what are the codal provisions? How to do that calculation? I don't know. And I think such things in software, once you know that pressure, you may do it in software. Even in STAD or ETABS, you can do it. But finding out that pressure is important. So, anyone in the audience who has worked on shuttering design for uh, bridge piers, do we have anyone in the audience? No. Mr. Akash Bawar is asking, can corbel-like detailing be used in that case? Yeah, corbel-like detailing you can use for the cantilever part, but your question was related to whether the column reinforcement of the above column can be taken and embedded into the column below. That was your original question. So that will depend on the, uh, as I told you, it will depend on the geometry that you have. This corbel thing is for this cantilever span. That of course you can do. Online Guru is asking what are the best ways to learn connection design. I don't know. We have done a course on connection design, which is quite detailed, and you will find it helpful. But then connections, you can have so many different connections that it's, I mean, you need to apply the knowledge for your case to case situation, because there are so many different connection type possibilities that you may have to apply some concepts from your own side. But we have done a course on connection design where we have covered a lot of different aspects for different types of connection design and detailing using manual calculations and on idea statica. So you may have a look at that. Okay, thanks. So any other question we have? So we have taken all the queries on the Google form, and we have also taken the queries in the live chat. So do we have anything else? Mr. Nehal is asking, in a mezzanine floor, if a column is connected with beam and only front beam of building is not there for double. Huh? Okay, in a mezzanine floor, if a column is connected with beam, is it a short column or long column? Right. Short column, long column, that will depend. So your case is similar to what we had over here. So let's say this is your mezzanine column. It is not connected in this direction. So this is the front column, let's say. Assume this to be the front column, building front. So at ground zero level, it is connected. At mezzanine, you don't have this beam. At the mezzanine level, your front column does not have a beam in this direction, there is no beam. And then again at the first floor level, let's say, again you have got the beam. So your column effective length will be, you will have two different effective lengths of this column. About the YY axis and about the ZZ axis, your column lengths will be different, effective lengths will be different. So you need to check this ratio and this ratio, and if it is more than, of course, you may have to add the sway factors over here, and if this is more than 12, then it will be considered as a long column. If not, then short column. This is, I'm talking with respect to RCC design. Mr. Akash is asking which is the AuxEn's upcoming course. Right now we are doing a steel design course on AISC codes. After this we will do a concrete design code using the ACI codes. So that will be sort of a complete basic package, you can say, for uh, RCC and steel design as per American codes. Mr. Nihal is saying, will RCDC design from StatPro? Yes, it does. In fact, now RCDC has been acquired by Bentley Systems, that is StatPro company. So RCDC is completely integrated with StatPro. So directly from Stat, you can take your model to RCDC and do the post processing. That means do the design. Mr. Mehdi Ali Khan is asking, suggest a book for raft foundation design. I don't know. I have never used. I think Tomlinson's book, people say it's a good book for overall geotechnical, not only geotechnical, yeah, I mean, for geotechnical structures, Tomlinson's book is a good book, but I have never referred it. Neither I have referred any book for raft foundations. So, anyone in the audience, if they can suggest a good book for raft foundation design. Mr. Nihal Pradhan is asking, for double height, do I need to change anything instead? Yes, you need to give appropriate effective lengths. You need to give effective lengths to the columns. For the columns which are double height, that means they are only getting tie about one axis. You will have to give the appropriate effective length parameters. Mr. Akash is saying tentative dates for start of the course, maybe after a couple of months. After a couple of months, we'll start, maybe. Good. So, anything else? So, I think that's it then for this session. We have answered all the queries in the Google form, and we have also answered the queries from the YouTube live comment. So, this Google form is there, and I mean, throughout the week, you can keep putting your questions throughout the week, and as you know, once every week we conduct this live session. So I'm just pasting the Google form over here. Yeah, this is the Google form, and if you want to get in touch over WhatsApp, I'll just share the link through which you can connect with us on WhatsApp. So just a minute. Yeah, so this is the uh, link if you want to connect us with over WhatsApp. So I think this is all for this session then. We will meet you next week. And today we got late because I had gone somewhere out. I think next week also we will start at a similar time, around 12 noon. Okay. All right. That's all for this session then. Thank you for joining us. Have a good weekend. Bye bye and see you next week now. Bye.